Yeah, I want you to kind of do it as a group because if we compartmentalize too much, I think we'll just encourage more compartmentalization.
I feel like I know this.
So I want you to like look at them as like, all right, how do I put this all together?
It's not knowing.
And this is a review of pretty much all of the antiderivatives that we've seen up to this point in some form or fashion.
But, there's a big but there.
We're going to stay on topic though. I really hope that you would take what I'm saying seriously. Because if you don't, when you're 35, you'll be like, man, Mr. Anderson actually was sort of right.
When I'm 45 and have diabetes, I'm going to shoot you an email and be like, hey.
Well, feel free. Feel free, yes. All right, so number one, I want to kind of run through the list real quick of the possible things that could be going on when you encounter a fractional integrand. So ln is a good place to start, like maybe it's that. If it's not, maybe we flip up. If it's not that, it could be arcsine or arctangent.
You're arctan twice.
Oh, should it be arcsine? Sorry about that. There we go. So with number one, if it's going to be ln, you'd ask yourself, is the derivative of the denominator the same as the numerator? And the answer is no. And it's not even close, right? It's not just off by a factor of 5 or 7 or something. It's totally a different form. And so we reject natural log as a possibility. The next thing I come up to is flip up. And so in my mind, the best way to handle flip up is to like either mentally or literally just try it and see what happens. So if I did do flip up, I would get x to the third minus 2x times x to the negative 2. And if I were to stop right there, it's definitely a no-go because the derivative of the inside is not that other factor. But what could I do that would maybe make it possibly work?
Distribute the x.
If I simplified, I think we're going to see that this is what works. So this would be x to the first minus 2 over x, or 2x to the negative 1, however you want to write that. And this got really, really simple all of a sudden, right? When we simplified, you can look at it and say, well, the first term is really easy, and the second term actually does go back to an ln, doesn't it?
I got really confused because I wrote it as 2x and then I'm like, oh, the antiderivative.
And did you get zeros?
I was like, oh.
Yeah, ln. There we go. Nice work.
Nice.
So 1/2 x squared minus 2 ln absolute value of x plus c would be that final antiderivative. So questions on that? A lot of this is about the thought process. A lot of this is about how do I select the thing that makes sense versus just like random shot in the dark and hopefully that's the thing. Or I want to be sort of... our process needs to be methodical. So same thing with number 2. I would put the same list out to the side and say ln, flip up, arcsine, arctan, like so. So natural log. We would ask ourselves, is the derivative of the bottom the top? And the answer is?
No.
Nope, it's not. And importantly, it's not even close, right? What term is missing from the top? Or what factor is missing? There's got to be some kind of an x times some number maybe, or just an x. That's not there. So it's not natural log. Flip up. Again, I think trying this out would be wise. If we do this, this is what I mentioned yesterday. Here's where there's like all kinds of potential for some really awful math. For example, I've seen this over the years. You've all seen this maybe from a classmate. Never you. It's always a friend that does this stuff. Right? This is really atrocious math. You can't distribute that exponent over a sum or difference. So this is bad news. But then, aren't we still in bad news territory with our flip up? Yes. Timmy is way off. But even if you ignored the whole Timmy being way off thing, what are you going to get?
0.
0 in the denominator, to the 0, all that stuff. It's not going to be it. So we've eliminated ln and we've eliminated flip up. So it's got to either be arcsine or arctangent. So I go back to the original, and I get the 2 out of there. And I ask myself, all right, if it has to be arcsine or arctangent, of those two, which would it have to be? Have to be arctan. Why? What do you see? Yeah, no square root. That'd be our first big hint for sure. Okay, so then we're settling on arctan. We're saying that's probably it. Let's just make sure we have our u and our u prime and our a all set. What would our u need to be if this is going to be it? 2x? How about the u prime? What about the a? 3. Okay, so this ensures that the denominator is exactly what we want. What would the numerator have to be for this to actually be arctan?
You need a 3 when we have the 2 already.
I took the 2 out. I don't know if you see up there, I pulled the 2 out
Right.
as a constant multiple.
Couldn't you just multiply?
I could put it back in,
Yeah.
or I could
Multiply by 6.
multiply by 6 and then divide by 6. Give me the 1/3. Either way works fine. I like that you see that, Logan, because I want you to be flexible in your thinking. We could just put it back in and multiply by 3 and 1/3, or we could leave it out and multiply by 6 and 1/6. That's going to get us to the exact same place. So I'll just do this since I already have the 2 out of there. And this would end up giving us 1/3 arc tangent of 2x over 3, and then don't forget the plus. How's this going? Is the little, hopefully, logical progression off to the left there making sense? Okay, so then number 3 is where we take sort of a hard right turn into sort of something totally different. What do you notice about number 3 that makes you think, gosh, it's none of those? It's not ln, it's not flip up, it's not arcsine or arctangent. There's a big hint that says we need to kind of ignore that and go with something else.
The degree of the top is bigger than the bottom.
Look at the degrees, right? So if the degree of the top is bigger than the degree of the bottom, we follow one procedure, and that would be division. And synthetic division would be a nice choice. So off to the side, I just go 4, 1, 8, negative 3, and 2. Right? We just drop down the first one. So I'm getting, ooh, it gets kind of, is that really right?
Yeah.
182 over there?
Yeah, that's right.
All right. Should have thrown in a different positive or negative in at some point. Made the numbers a little smaller. In any case, we end up with antiderivative of x squared plus 12x plus 45 plus 182 over x minus 4. We haven't found the antiderivative yet, but that's our simplified integrand. Making sense? I'm seeing really calm faces, indicating that yes, this did go okay. All right, so then maybe a final answer, 1/3 x cubed plus 6x squared plus 45x. And what does that last term end up being? Yeah, it's a natural log. So 182 ln absolute value x minus 4. And don't forget your plus c.
Nice.
Okay, so number 4, did you guys notice that number 4 looks really similar to number 2 with like one small yet important difference? And it is really an important difference, right? Instead of a 2, it's an x. So if we were to zoom in on that one a little bit, and I go through my little process of, is it natural log? Is it flip up? Is it arcsine, arctan? Which of those could it be? You look at ln and you ask yourself the question, is the derivative of the denominator the same thing as the numerator? And what's your answer? Pretty close, right? It's not exactly right, but if we just multiplied by one constant factor, we would be there, wouldn't we? So times what? Times 8. Right? So derivative of the bottom is 8x. So I'd multiply the top by 8. Now I've got a perfect chain rule leading to natural log. So I'm really confident it's natural log. I don't want to forget to also multiply the outside by 1/8 to balance that out. So this goes straight to 1/8 natural log. I don't have to put the absolute values here. Do you guys know why?
Oh, because it's always positive.
Yeah. X squared, always positive, times a positive 4 plus a 9. It's going to be positive no matter what your input is. So
If you leave the absolute value signs there,
that's no problem. Not a problem. Just pointing out you don't have to. What did I try to make this look like?
A tangent or an arctan?
I tried to make it look like an arctan, right? Like that 9 plus 4x squared looks a lot like an arctan. So this would be a place where it'd be understandable, very easy for someone just to immediately to jump to arctan and assume that that's it. And that's why I put this in the order that I put it. Make sure you check ln. If it's not that, then move on to flip up and so on and so forth. Work through that progression really quick. I think you can do it quickly eventually, if not already.
Why didn't you put the I didn't catch that. Why didn't you put the absolute value there?
Simply, I could have, and if I did, it's not a big deal. It's not wrong at all. I just looked at that input and realized that whatever the input is, squared will make it positive, times a positive 4, it'll still be positive, plus a positive 9. There's no number I can plug in for x that'll make that input negative or even 0. And so I don't need the absolute values. Just don't have to have them. Okay, how we doing? This is just a big mishmash of all these different forms, and I just want you to get used to being flexible in your thinking. So, if you're doing okay, why don't you flip over to the next page, and I'll flip over there too, and let's try the next set of 4. I think this is it for this. Oh, there's a set of 5. My bad. Ooh. And Forrest, you might have to come to the front for some of these. I don't know. Okay, so we're just looking through, same process here. I don't know. Justin and Peyton, I guess, have them back there. You guys have your thing printed off. You want me to zoom and then you can peek off theirs too or something? There's the first 3 at least. There's 2 more. Second? Yeah, what's up? Oh, yeah, so you can't integrate. Yeah, that's not good on a couple different levels. You can't, how do I put this? You can't integrate a product factor by factor. So for instance, if I've got, and it's kind of cool that you ask about this because we're going to talk about today and tomorrow an advanced way to handle, Forrest, the integrand or integral of a product. But if you have like integral of x squared times cosine x, you cannot just say that that's 1/3 x cubed times sine of x.
So you can only do like plus or minus?
Yeah, if it was x squared plus or minus cosine x, then you can go term by term, but you cannot go factor by factor. And the reasoning on that is, shouldn't you be able to take this and differentiate it and get what we started with? You're going to have to use a product rule here to differentiate this, and you're never going to get that. So yeah, so you can't do that. That's kind of what you use.
But if I use this one, like the x fixed, like x squared,
Yeah. So in this, for ln, I would say the opposite pattern will typically be true. I think always be true. So of course, with the degrees, for it to be ln, the degree of the bottom would always be bigger than the degree of the top if it's going to lead to ln. Right. This is x to the first. That's x to the 0.
okay. So, oh yeah, I see.
And the other thing, it looks like you have ln of x squared right here. So if we just focus just on that part only,
Yeah.
if you had this, like if that's all you had as an integrand, this is definitely not equal to this. And that appears to be what you have going on. Okay, so the reason why is, shouldn't I be able to take this, differentiate it, and get that? So ddx of ln of x squared, isn't this equal to 1 over x squared times 2x? According to the chain rule? So, and this would equal 2 over x. When I compare that to this, they're not even close. So if I was gonna do an antiderivative of 1 over x squared, I would flip it up and turn it into a power rule for antiderivatives. So this is negative x to the negative 1 plus c. Yeah, so be careful with that. And that's why I want you to go through it like all those, so we go through that little process that I've had you guys go through with these. I want you to ask yourself that question. Is the derivative of the denominator equal to the numerator? Now when you think about that one over there, the 1 over x squared, what's the derivative of x squared?
X over
Dude.
Is the numerator 2?
Give me that.
Yeah. this off by a factor of 2. Easily. It was. But the fact that there's an X out there,
Did you get over 36? Did you get a negative on 36? Negative, yeah. Tell you what, dog, this was not.
But in a situation like that, and you can't do, you can't, like, when you have a product, yeah, like, when you flip up and you have, I'm not sure what this is.
What's the name of our boy band? What's the name of our boy band?
Oh, okay, gotcha. Even still, when you do flip up, you need to multiply that through.
I'm trying to think of
Just
like.
just a couple of terms instead of 2 factors.
Number 9 is gross. Never mind.
You're welcome.
Trying to think of something.
Okay, so for those that don't have it printed off, maybe you're done with 5 and 6. There's 7, 8, and 9.
Yeah, so many good notes.
For goodness sake, print it off, bring it tomorrow. If you haven't.
Some juicy, complete the squares.
Oh boy, this is gonna be fun.
Tell you what, dude, that's some nice complete squares.
So here we go. Number 7. Did you guys dismiss ln pretty quick?
Yes.
Clearly the derivative of the bottom is not the top, so we get rid of that. Did you also dismiss flip up pretty quick too?
Yeah.
Oh, sorry. If you try the flip up, don't you get like quantity to the -1? You get this whole division by 0 thing. Yeah, we've already eliminated natural log as a possibility. So doesn't this lead us to arcsine or arctan? Yet it doesn't look perfectly like either of those. But of those two, which is it definitely not? Yes, no square root, so it's not arcsine. So we're led to believe that it's maybe arctan. What do we need to do to get this in the form that actually would confirm that? Complete the square, somebody said. Yep. So off to the side, we complete the square. Here's what that would look like for this one. I'd go x squared plus 6x. I'd leave space and put plus 13. What's my new term that I add in? Say again? Plus 9. So I'm going to go plus 9 minus 9.
Nice.
So x plus 3 squared. It ends up being plus 4 out there, doesn't it?
Yep.
So really what this was, I'll get the 7 out. This was really 7 times the antiderivative of 1 over 4 plus, look at that, it looks like an arctan antiderivative now, just like we hoped it might.
That's just nifty. And Timmy didn't do anything wrong.
And I don't think Timmy even, he did a little bit. A little bit.
What did he do? Oh wait, never mind. I'm tripping. I'm tripping.
So u would be x plus 3, u prime would be 1, but then the a value, that's the one, right?
Yeah.
A is 2, so the numerator needs to be a 2. So I'd go times 2 divided by 2. So 7 halves arctan x plus 3 over 2 plus c. What do you think about number 5? You guys have any questions about 5? This one okay? Okay. Number 6. Let me get the 6 out of there right away. Okay, so let's just start off with this. This is definitely not natural log. What is the one symbol that tells you that it's not natural log? The square root really messes that up in this case, right? So not natural log. Is it flip up?
Nah.
It's possibly flip up, but why is it not?
X in the numerator.
Yes, we need an x in the numerator for it to actually be that. So we eliminate that. That leaves us with either arcsine or arctangent. And of those two, if it has to be one of those two, which one would it have to be? Arcsine because?
It's square root.
We got the square root in there. So I'm going to come over here and realize this is pretty well set up. I don't have to do any completing the square. I do need to identify my u prime, and my a. So what would be my u? Good. How about the a value? Meaning the u prime would have to be 3. What does the numerator have to be for this to be a perfect arcsine antiderivative?
3.
It's got to be u prime, which is 3. So I'd go times 3 divided by 3. This leads me directly to 2 arcsine of 3x over 5. Don't forget the plus c. How are we doing? Any questions? And these questions, I think, would be along the lines of, like, thought, right? Like, why would I think to do this? How would I know to do this? How would I know to even think about that? That's maybe what we would be going over. Okay, so let's take a look at 7 and 8 and 9. So 7, obviously a fraction. Is it ln? How do we know that it's not ln?
It goes from 6 degree to 2 degree.
Right, and what would the numerator need to be in order for this to be an ln?
A fifth.
Yeah, x to the 5th or something x to the 5th. And it's not. So that just means it's not ln. So instead of like raging against the fact that it's not ln, like why isn't it ln? Just let it go and think, what could it be? Is this one a flip up? Why is it not a flip up?
Because it's quantity squared to the negative 1. Quantity to the negative 1. Which would
It'd be
give us
quantity, which that'll always lead you to problems, right? Yes, very true. And that leaves us with arcsine or arctangent. And of those two, which one would it have to be if we're down to those two choices? Yeah, there's no square root, so it'd have to be arctan. So identifying your u's and a's and all that here is maybe a little bit tougher. What did you guys have for a u on this one? 3x cubed. Makes a lot of sense, right? Okay, so that means our u prime would be 9x squared. What's our a?
7.
Okay, so then what would the numerator need to be? Like in general, what does the numerator have to be for arctan? U prime a. Yep, so u prime a would be 63x squared. So then you look at that and say, well, gosh, the x squared's there, so that's good. That means it actually is an arctan. But Timmy's off by a pretty big factor. We just need to multiply by 63 and multiply the outside by 1/63. And now this does perfectly fit an arctan. So I'd go 1/63 arctangent of 3x cubed over 7. Don't forget the plus c. Okay, how are we doing? Do we save the best two for last? These are the ones that I heard the most talk about.
Oh, this is good.
Okay.
This is the one on the
Peyton,
left
did you
side
figure out
where
8?
it's
You figure out?
Yeah.
You did?
Don't
Okay.
ask me my answer because it's probably wrong.
All right, well,
What's your answer?
I said don't ask Logan.
apparently, Logan, that's her current answer is don't ask.
Oh, okay.
Okay. So, number 8. Why is it not natural log? Because it's not.
Because math says no.
There's a square.
Square root. Yeah, that's often going to be the reason that it's not natural log. So we avoid natural log here. Is it flip up?
Yep.
Okay, let's investigate. Let's make sure that it actually is. The x stays in place. This becomes that when we do the flipping of the denominator. So now maybe we ask ourselves, is the derivative of that inside the same as the other factor? And the answer is almost. We're off by a factor of what?
Negative 72.
It'd need to be negative 72x. And so if I just multiply this by negative 72 and the outside by negative 1/72, then I actually have a really nice Timmy messed it up, but we fixed it situation, right? So it'd be negative 1/72 times this whole deal here, all to the 1/2. Divided by 1/2 is really times 2, right? And then don't forget the plus c. That would be a fine answer. You could also, get negative 1/36 if you went ahead and simplified the front two factors, but whatever.
Crazy stuff.
Did that work? Did you get it right?
Yeah, I did.
You got it
You
right.
tried to pull a little sneaky on us by making all those values squared under the square root.
I did. I was trying to make it look like what? Arcsine. I tried to make it look like Arcsine.
We
You were onto me. Yeah, I couldn't fool you. And that's a good thing, right?
Yeah.
If I can't fool you, that means you're figuring it out. It's not a malicious attempt at fooling. It's a
Completely
nice
malicious.
attempt.
Completely malicious.
So mean. Okay. Let's do our last one then, number 9. This one was maybe the toughest. It's obviously up for debate. But with this one right here, you can tell that it's not natural log because of that square root hanging out down there. You can probably tell that it's not flip up because when you get there, the derivative of the inside, it's not working either. So it comes down to either arcsine or arctan. And because of the square root, what did you pick? It's got to be arcsine. Okay. So then you think, cool, it's going to be arcsine. This should be pretty easy. But then you look at the thing inside the square root and you realize, whoa, this does not fit that a squared minus u squared pattern at all. So what do we have to do? Complete the square. Yep. So I'm going to come over here to the side. This one's a little tougher. So let's make sure we have this down.
This one had a little thinking going.
Yep, you got to think about this a little bit. So we're still going to group the first two terms and exclude the constant out there. But what's the one step that we have to do here that we didn't have to do on the other ones?
Factor it out.
Yes, the only way you can complete the square is if your lead coefficient is positive 1. And I need to factor out that negative in order to do so. And of course, maybe you remember this. This has implications for the future as well. So what's my number that I add? 9. Here's where this gets tricky. We want to say that we really just added 9 to this expression, but that's not true. Didn't we really just subtract 9 because of that minus out front? So if I subtracted 9 from the expression, how do I balance it?
Yeah.
I add a 9. Okay, so this is negative x plus 3 quantity squared plus 16.
Wouldn't it be x minus 3 because it should be x squared? Oh, no, we took the negative out.
Yeah, we pulled the negative out. Yep.
Never mind.
Yep.
Yeah.
You made me look, Julia. I thought, did I lose a minus sign? Please tell me I didn't. Okay. So then we go here, and now that we've completed the square, this now looks a lot like an arc sign, right? What does the numerator need to be? U prime, and isn't it that already?
Yeah.
So Timmy didn't mess it up. We end up with 8 times arc sine of x plus 3 all over 4. Don't pack up yet, and don't forget the plus c.
Wait, is it lunch next? Oh.
It is. Hey, but before we do, let me give you a preview of tomorrow. Okay? This is going to be a nice segue into what we did today, and frankly, for some of you, what we did for like all of last year. Meg, please listen. Nick, please listen. Into what we're going to be doing tomorrow. So this is where, I don't care who you are, unless you've been reading ahead, none of you have seen this before. Okay? So I want to no intro videos here. I just want to get a couple of thoughts planted in your mind, and we'll pick these up tomorrow. So the question has to naturally come up. What would we do? And I was talking with Forrest earlier. The question has to come up. What if we ran into an integrand like this, where it's a product, right? X squared times cosine of x. But there is no way to simplify it, right? There's no way to like multiply something together or do some division or complete the square. There's no way to do any of that stuff here. Surely there is a way to handle something like that. And there is. It is called integration by parts. Integration by parts. This is going to be important when we are integrating a product of a polynomial and a transcendental. And this is what I want to leave you with. I have a way to help you remember how to do this. So you can see over here on the left side of my little equation that we have the antiderivative of u times dv. It's a product, right? Is equal to uv minus the integral of v du. This just comes from the product rule. Maybe I'll show this to you tomorrow when we have some time. But the way that I remember the right side of this is this little phrase down here. Ultraviolet voodoo. Do you see it? UV minus the integral of V to U. And I remember that it's minus because voodoo is very bad. Bad voodoo, right? So ultraviolet voodoo. If you can remember that, you can get that right side set up, and these will go pretty well. Okay, so we'll practice some ultraviolet voodoo tomorrow. aka integration by parts. Looking forward to some new stuff with you guys.
Sweet.
Should be fun.
Thank you, Mr. Anderson.
Thank you.